Hi, my name is Kajal Majayal and I am in Physics 112 with Dr. Solis. My group members for the media project are Kirit, Danish, and Shivam. The title of our project is Effect of Rope Length on the Velocity of the Transverse Wave. For this media project, our group decided to look at the relationship between a wave's velocity and the properties of the rope. First, a prediction will be made based on the properties of two different objects. The wave was created by tying one end of the rope to a surface, and the user would then create a wave by moving the rope up and down. The production of a wave within the rope is the motion of disturbance along the string depicted in the image included. From the time it takes for the disturbance to reach back to the hand, a period has elapsed. During the same time, the end of the string that produced the disturbance has moved equal to one complete wavelength. This means that in the time of one period, the wave has moved a distance of one wavelength. This is where the equation speed equals wavelength divided by period comes from. It is important to note that the speed of the wave is determined by density and tension. Additionally, the period is the reciprocal of the frequency, and that allows for the above equation to be rewritten as speed equals wavelength times frequency. This equation states the mathematical relationship between the speed of a wave and its wavelength and frequency. Using the symbols velocity, lambda, and frequency, the equation can be rewritten as velocity equals frequency times lambda or wavelength. The period of the experiments were taken by using the time in the video, and frequency could be calculated by taking the inverse of the period. Using the equation v equals square root of f over mu, using this equation, it can be said a rope with more tension and less density will have a larger velocity. For the equations used, the main one is speed equals wavelength divided by frequency. The speed for video 1 will be determined through the Vernier Video Analysis app by analyzing the slope of the position versus time graph of the wave. The speed for video 2 will be analyzed using the equation speed equals wavelength over frequency. Speed of the wave can also be calculated by dividing the tension by the density and square rooting that answer. In video 1, a hose which is attached to a surface is lifted up and down to create a transverse wave, and from this video we can analyze the speed of the wave. For video 1, the speed is directly measured, period is determined from the video. In video 2, a string is attached to a surface where the string gets lifted up and down as well to create a transverse wave. The speed of the wave can be calculated from this video using the equation v equals frequency divided by wavelength. Period is determined from the video, and wavelength is also known from the video. Then the two values get plugged into the equations determining the speed of the wave. These equations show how they are all related algebraically, and by knowing two components, we can solve for each equation and determine the speed. Before determining the speed from the graphs of the videos, we predict that the wave in video 1 will move faster than the wave from video 2. Although the density and tension have not been calculated, we predict that the hose in video 1 has a larger tension compared to the rope in video 2, and thus would have a larger velocity. The velocity of the rope was approximately 4.7 meters per second, and the velocity of the hose was approximately 8 meters per second. In the end, this showed that our prediction was correct. The rope with a larger tension also had a larger velocity. The end. Thank you.